right. So last time we were working on this, we were working on migrating from I forget what we were using previously. Just like the OpenGL package to using GPipe, which is basically just a layer on top of that, and it's a little bit more deterministic. Actually, a lot more deterministic. So our game loop now kind of looks very nice. It's just a series of monadic actions within this context, this GL context. But right now, I believe we left off with a bug, or not a bug, but like a compiler error. So let me see where we're at. For a sec. Okay, it's just some, yeah, I think it's just some scoping issues here. So, let's go down to Google. So it's just telling us can't find these. This, yeah, it comes from Lens. So we'll just make sure we're importing inside of rendering. And we need to import. Is that what it was? Lens, okay. Then we go into our Cabal file and we just add in lens. Okay, now we just have these two, and this is just probably from GPipe. Got to find exactly where it is. I'm sorry, polynomial. Okay, see what this rasterize function is all about. Where's something that I wrote, maybe? GPipe-Core. Okay. Doesn't seem to be included in our package here. We can probably build our own Hoogle, but I don't know how to do that. I usually do that with Obelisk, so we don't use Obelisk.
Sorry, I left for a second. I'm hanging out, but I'll be on my phone. What were you trying to do?
Basically, I'm just realizing the reason I can't find any of this stuff is because it's not in Hoogle. It's coming from the GPipe-Core thunk, which we took from and I guess because I'm
You could probably set up
remembering.
a Hoogle with your own projects pretty easily. I just learned. What do you remember what your
Yeah,
shell.nix looks like?
what my shell.nix? Yeah, let me a second.
Yeah, I think if you're using shell 4, I think you can literally just say with Hoogle.
Okay. Let me see what I'm using here. I'm not using shell 4, I don't think.
I wouldn't know how to do it off the top of my head.
Yeah. Well, I'm just gonna look at the source code
Yeah.
because it's really not that big.
Yeah.
I guess we can. Let's search as the file. Can we search? I guess I'll just do a search here. I'm gonna search for. Polygon fill. Huh. Weird. So is that just. It's been so long. Okay, let's just look at what this rasterized function is. It's been like a month since I worked on this, right? So give me a. I'm not remembering why I wrote polygon fill. It could also be a hallucination because we used a little bit of GPT here. So let's just work our way back. Rasterize. Fragment stream. Okay, so primitive stream. What the heck did I just. Okay. Side, a viewport, and a depth range. Where are those defined? Okay, search for those. Okay. So we don't really have documentation. So I'm just going to open here. This will be our documentation on the left. Okay, so Yeah, this is just wrong. Side. Side is just front. Let's do front. We don't need anything more. And then we need a viewport. Viewport lower left. The viewport in pixels coordinates where 0, 0 is the lower left corner. And pixel coordinates. So then it would be okay. I'm gonna just put this. Then we also need the depth range. Fragment depth range to map the canonical view z coordinate to depth range are collected 0, 1. So I actually don't really know much about what this is. Gives map. Okay, we're just gonna do depth range with 0, 1. Okay. Okay. And then it needs our primitive stream. And it returns a shade. Wait. There's our prims, frags. Oh, I see. So that'll give us, because we're running inside of a shader. Yeah, okay, so because here we're running inside of, just in case anyone's maybe a bit lost, we're right now compiling our shader inside of our initialize rendering function. So our shader is basically going to do a couple of things. It's going to get the primitives, which is like the, oh gosh, like the actual, in this case, it'll be the vertices, I believe, to primitive stream. Well, this is just creating a shader, so it's not actually, there's not actually any data coming in yet. So the first thing it's going to do is going to convert it. It's going to get the primitive stream from this shader. All right, two primitive. Let me look. Sorry, it's been like a month. I'm making shit up now at this point. Let me just look what this function does. Oh, this is going to be a pain. this is the primitive stream file. Create a primitive stream for bin. Okay, yeah, it's just a way of bundling. So a primitive in this case would be the group of vertices that form either a triangle, a point, a line, whatever we've decided based on our rasterization function. We've set up, I believe, triangles, or we will be using triangles. So a primitive is a single triangle. So at this point, basically what it's doing is it's going to take, so this is setting up, it's a little like abstract because we've got such a nice like type system. Like normally what you would do is you'd have like multiple files that you'd actually be writing and then piping them together. Here we're literally, it's doing a lot of this for us, which is great. It just took me a second to realize what we're doing here. So we're creating, effectively what we're going to do at the end result of this is a shader. What does a shader do? It takes pixels, or it takes vertex information or just information about the scene and converts that into pixels on your screen. In this case, we're giving it a bunch of vertices. Those vertices are going to be the paddles and the ball for the Pong game. And so we're going to give it those vertices. What it's going to do is it's going to figure out, based on the coordinate system of the window, where it's located on, like actually physically located on the screen. Like for example, you know, my monitor, like 0, 0 on my monitor would be way down here, right? And so effectively what the GPU is going to do is it's going to do a translation of, okay, where's the position of the window, right? Because if you move the window around, everything else follows. So it's where's the position of the window, which we have here, our window position. And then where is the viewport within that window, okay? And we're saying our viewport in this window, we're going to take up the full window, right? The entire window is going to be our GL viewport. You could have this be like a small isolated window in like a bigger like control panel or something, right? And you could change the viewport to be just a section of the window. But we're just saying set it to be the whole window. Start at 0, 0 and go to the full width and height. And then the next step is, okay, well, what pixels do you want to draw in that? So now we have basically effectively a box, which is just going to be an array of pixel values, right? It's now a 2D array of pixel values. We're working in 2D, so we don't have to do any translation from 3D to 2D. There's no perspective matrices or anything yet. So it's literally just a direct copy. That's why we can just go effectively just copy this data directly in. And so the first step will be the vertex shader. Vertex shader is literally just, well, in this case, it's literally just popping it right through, because we're just passing our primitives directly into here. If we wanted to, this is probably where we would intersect this. Like if we were doing 3D, we would probably need to do some kind of transformation. We would definitely need to do the transformation before we get to the fragment layer. So somewhere in here is where we would take these primitives and modify them based on the world coordinate space. But for 2D, we just need to pass this the primitives directly into this rasterize function. It seems this rasterize function is actually just set up to take primitives and give you a fragment shader, or to give you fragments, which is great. So what is a fragment? A fragment, you can think about a fragment as like something that's actually on the screen, something that's been drawn to the screen. There's the vertex shader, which are your vertices. Those vertices make up triangles. And then the colors within one of those triangles would be a fragment. And then all of the fragments together create the scene, if that makes, I think that might be a good way of thinking about it, right? It's your scene is fragmented by all these different vertices, and effectively each one goes through a pipeline, shader pipeline. Each one gets its own core on the GPU for calculation, etc. So once this, basically, like there's a lot that's actually happening here. This is actually making a call out to the GPU, and it's going to give us all of the fragments that it's rasterized. And again, we're effectively creating a function here. We're not actually doing anything. We're declaring a function here, right? Like this is going to give us back a shader that is a function. So this is not a like fully applied result, which is kind of the power of doing it this way, is that we're effectively creating a very specific function and that we're calling shader, and then we're going to send that shader back to the main system to actually render things, right? So we'll see in a minute how we use this shader. But yeah, so that's kind of how we've gotten to where we are here. And so inside of this compile shader function, you can see we're creating another do block inside of this do block. And so everything in here now is in the context of this shader function. And you can see that, and I'll actually show that because I think that's valuable. For example, I'll start just because I'm on toPrimitive stream. You can see here toPrimitive stream return, the final value of toPrimitive stream is this shader monad, right? You can see shader OSS is wrapping this primitive stream. So what, like the actual value, you could say like the value that we're getting effectively is this primitive stream, which has this vertex format. And I mean, primitive stream is also wrapping this vertex format. It could be just a type on its own. I haven't looked into it. Like you can have polymorphic types, right? This would be like a generic type. So it's saying primitive stream has this vertex format, but effectively this is what the value that we're going to get when we run this shader, right? That's a good kind of a way of thinking about it. We can either run the shader or we can ignore the shader, or quote unquote ignore the shader. And so here what we're doing, we're effectively, when we're inside of this do block, we are now operating within the context of this shader. And so anything that and I'll show you that. So if I go to compile shader, that's probably more relevant to illustrate this. If I go internal compile shader. You can see here that this takes in a shader as its initial argument, right? So we're saying here that as long as this first element is a shader monad, anything that is within this context of shader, then it'll be able to compile it. And so what we're doing is we're just defining that shader. or that we're effectively creating that monad here. And so you could also, like, if this is like maybe slightly confusing, you could have like a function, like you could strip all this out into a separate function, right? But you can also just go in one level, which is a nice way of keeping things. It really, at that point, it's a matter of preference. In other kind of other mentors might tell you, like, if your functions are longer than 5 lines, you gotta make it another function. But my argument is that breaks. A, it can break referential transparency if you're not careful, and B, it kind of breaks. I forget if it's Miller's law or Moore's law, but like your brain can really only make like 7 to 9 logical jumps before it forgets what the first one was. And so, like, the more logical jumps you're creating for yourself, the harder it is to understand. So I would say, like, make your function make sense as a function. Don't worry about how many lines. Don't worry about, like, oh, like, this part here is, like, creating the shader. And maybe this becomes, like, super long and we want to do that. But don't be too worried about, like, preemptively, because what's going to end up happening is you're going to take this block of code, you're going to put it down here, you're going to name it whatever, right? And then you're going to go like this. And, like, have you really made anyone's life better? No, you've just made it. Now I have to look up what my function does. And maybe it makes your life better if you're going to reuse that function, right? Or if it's really hard to understand, and giving it a good name just hides it. But don't preemptively worry about that, because there's almost, if you become obsessive about it, there's no end to it, and, like, you get developers that are, like, just doing way too much in that regard. Anyways, back to making fragments. Okay, so if I go, oh yes, I need to look up that function again. Be in here. So yes, takes our primitive stream and then gives us a fragment. So literally, it's just this then. Sorry, I'm just looking at these prints for, I think we probably want. I'm turning this from a V2 to a V4. Ah, I see. Okay. The type system will tell me if that's wrong. Okay. And then we're setting our fragment color, and then drawing the colors. So yeah, so this has actually, this shader will actually just draw the full. Okay. Cool. I guess we should just see what happens now. Mm-hmm. Okay. New window. Okay, this takes a window format and window parameters. Okay. I guess this is just incomplete from last time. Window format. What did I just do? Oh, there is. It is on package. Thanks. Oh, I see. Okay. Aren't there just defaults? Hmm. Also, Toby, I am using GPipe-Core. We've forked our own version of it. We had to solve some compiler issues because the GPipe has been unmaintained for like 3 years. So we just forked it and solved it for our own purpose. But yeah, it's a fork of GPipe-Core, so the first one you sent me is correct. Window format color. I'm just like I don't normally I'm usually use defaults. I don't know which window format to use, and that's where I'm going to defer to GPT.
Yeah, I bet you could literally copy paste that type into ChatGPT and it would be able to
Yeah,
tell.
exactly right. Like it's this one here. It's the format. I just don't. I know what these are. It's just I don't know what one to choose. And if I choose the wrong one, everything's gonna just blow up on the screen. So I'm just gonna. These are those things that you like set up once and like you only change them if you're like doing something very specific.
Yes. Yeah, I can't even remember what a stencil is. I remember the word, but
Oh, stencils. Yeah, I mean, it's exactly what it sounds like. It's
right.
like a pre-formatted arrangement of pixels, or like a
Right.
prearrangement of pixels. Yeah. I have these options for
Like the silhouette of a character or something. Or like the outer.
I mean, that's like it's not how the computer uses them, but yeah.
True.
I do forget. It's not relevant right now. I'm on format. Give me a second.
Yeah. Yeah. Fair. Fair.
RGBA 8, yes, I have heard that. Okay, so then we just go window format, color. Okay. What is this C? No. There's that. Okay. Right. Window format, window parameters.
It seems like each instance of that class has a particular type named window parameters.
Yeah. Context handler.
Is there a specific instance of context handler you're using?
That's probably what I need to. I guess it would be. Let me see. Let me see. Where would I see the instances?
Oh, if you go back to the Google.
Yeah. If I go to where's the context handler? Too much going on here now.
If you scroll down, you should see instances. Yeah. Oh, there.
That's context T.
Oh, just scrolled past. Oh.
You know what I mean? No default instances? Is that what that says? No. Class implementing a window handler that can create OpenGL contexts. I just don't know. Oh, associated types, contexts. I know those are just. Because like I recognize context T. I just don't know what this. I mean, maybe context T is a context. Like maybe context T implements.
Yeah, it should say under it if it's in the Google. If context T implements it.
Yeah.
But
It's not.
I would even that is weird. I would search the code directly and see like where not context T, the context handler.
Yeah. Yeah, I can grab. Just need to know what this does to even be able to start reasoning about it.
It's pretty hard when it's devoid of context.
Ha.
Thank you.
Yeah, so this is just what I was looking at before. So this is not what I want. Let's see where it's used.
Maybe say instance context handler.
Yeah.
Or read through it manually.
Yeah, I was reading through it, man. I don't see it, but I'll just. No.
Yeah, it's very strange because it would have to evaluate to something. It would have to pick some instance at the end
You know
of the
what I
day.
mean? Do you understand why I'm confused?
Oh, yeah, that's fair.
Because I have I'm working within context T here, right? Like this monad is context T, right? I'm in context T. So whatever this context handler is, like if I'm trying to call a function, like if I'm looking at the function we're trying to do right now is new window, and so it's saying here that window parameters And so this is interesting. Context T CTX. So would glfw.handle then maybe be I don't know.
I mean, it can make sense.
Yeah, right.
Yeah, like it's always possible. It's like a Google, not issue or bug, but like just Google doesn't pick up like what instances it has. You could always
Just to confirm, with something like this, window parameters CTX. This CTX, this is a polymorphic type. So and this will be it'll be assigned a type at compile time based on whatever this CTX is here. So it would be glfw handle. So this window parameters CTX would effectively, once this is all, like if we were to throw it in here, then it would be Windows CTX or window parameters glfw.handle. And then that would be fine because it has a type that is part of this context hand. I don't know.
Yeah, and you can always check this by just asking the type of new window in your code, like with a type hole.
glfw.handle must have an instance of context handler CTX to the constraint. Like it must, right? Let's confirm.
Mm-hmm. Yeah, exactly. And again, like we could confirm this by just doing the type hole. I think that's the easiest way to go.
Oh yeah, okay. On new window.
Mm-hmm.
Or sorry,
Yeah, a new window, not when. That's what you're thinking.
so I would go like this. That's what you're saying?
Yeah.
And then just compile. Like putting holes in my code. Yeah. With actual type glfw.window-config.
Oh, that's
Wait, sorry,
you want to go one up.
I was reading that too quickly. My bad. Found, that was what we had before. Found type wildcard, standing for window format. Let's see. Yeah. glfw.handle. That's what I had in the thing there.
Yeah.
So it is this glfw.window-config.
So yeah, it must have an instance of that. The other option you could do is if you really wanted to check it, but I think this confirms that, is like going into a REPL and asking like the :I on like glfw.handle, and it will show you the instances that it has.
Oh, it didn't load in that.
Oh yeah, you just gotta import whatever glfw is. Peace out, Zen.
Yeah, context handler parameters, which probably. Yeah. Class.
Yeah, it's definitely confirmed.
Yeah. Cool. So that's how they did that then. So that means then I should be able to just construct window parameters within this context. Implementation specific window parameters, initial size, border decoration. Is there a default to this? Window parameters.
Well, if in terms of default, there might be a default for glfw.handle, but
Yeah, I know what I need. So I need at this point now, the goal is we need to construct this window parameters type, but I don't really know, because the window parameters would be, oh, I see what you're saying. Because this would be defined now by glfw.
yeah. So I mean, if there's
I see.
Yeah.
It's like an abstract, almost it's defined.
So you could.
Yeah,
exactly. Sorry, I keep interrupting you, but yeah, so like you could create context on glfw.handle, for instance.
Yes. Yeah, but what we need to do, we need to create window parameters, but this window parameters CTX, this is window parameters glfw.handle. So where's the actual definition of that type now? You know what I'm saying? Like, I guess that would mean that it's glfw.handle would be the actual type, because this is effectively now just like a wrapper, effectively, right?
I mean, it did say that the instance of it was defined somewhere, right? In the REPL?
Yeah, okay, so that would be where the actual code for window parameters.
Yeah.
Interesting, okay. But then, like, what makes context window different from window parameters? Literally just the label and where we use it and how we use it.
Yeah, I mean that could be all it is.
Yeah, I'm just trying to understand. Yeah, I haven't worked with this.
Totally. No, I think sometimes too, like just sometimes like the label really doesn't do anything besides provide the label. Like in Haskell, I noticed that a lot.
That's extremely valuable. It's just I'm trying to understand if that's really what all that's going on here, because it seems that, like, if I were to follow this train of thought, right, like we have window parameters and we have context window, right?
Totally.
Both of these are just types, so these are type aliases, right? So that would be a type alias for whatever CTX becomes.
Yeah, more specifically a type family, but ultimately almost like a, well, I guess it is a type alias because it is type.
It's a type. Like this here is a type alias. It's a type family because it's inside of a class. But I learned about this yesterday. Actually, it's a associative type family or something. There's two types of type families: there's associative type family and then the closed type family, which is where you type like type family. But yeah, okay, cool. So that's what that's doing there. And then so then really, once context handler gets value for CTX, these two are exactly the same, except for the label, which determines how it's used.
Yeah, sure seems like it.
Right.
At least we can operate as if that was the case. Yeah. Maybe there's a difference, and there probably is a difference in how it's used. But we can ultimately.
That's effectively.
We should be able to make that assumption.
These are like contextual wrappers for whatever we put here, and in this case, we put glfw.handle. And so that means if we look here, context handler parameters.
It's kind of cool, like what we're trying to figure out here, though, because it's a very general way to make an API. We have a class, like it's kind of as close of a feel as we get to object oriented, but like we're not doing object oriented, of course. Like we're kind of defining like parts of the data. We're not actually even defining the data, but we're defining sort of like the input or form of the data, and then the functions along with it, like for a normal type class. And the reason, I guess, the better way of putting it than having it any relation made to object oriented is just to say this is a very generic interface that we are able to make with a class that has like, you know, associated type aliases and associated data families.
Yeah. I don't know. Okay. Window parameters CTX. So then this just. So then all I need to do is put in. I don't want it to be fun. Need window parameters. That'd be for run context T. That'd be as well. Window parameters.
After you type that,
Yeah, what's up?
sorry, I don't think I realized what you were searching around for. So, like, if you go back to new window, what if you click on the, or like window window format?
I've got window format.
Oh, okay.
I need window parameters now. When I click on that, that's where it brings me to this associative type.
Oh, I think, like, I think, or, like, with it just being a type alias, right? Like that, you know, that just is a glfw.handle, I believe.
Yeah, yeah. I guess then I just need to figure out how to create. Like I'm just kind of having a brain fart. Like if it's
You
GLS,
like that's it.
I
Like
just need to create
you're
one.
thinking you need to create a type, like instance of that type alias, right? But like you already have what you need there, I believe.
No, I don't have. That's where I'm confused because I know I need to pass like this needs to be a GLFW handle, right? Like some way. But
Gotcha.
I don't
Okay.
like you know what I mean.
Yeah.
Like I don't have one as far as I'm concerned, or as far as I'm aware. Like, but I do. Like I guess I do because I'm in this context GLFW. Yeah, this is where I'm a little confused.
Wait, doesn't new window take a context T?
No, it just takes this. New window.
Oh, you know what? This might be just something you can generalize. Okay, so like how do we get the CTX from the context T, I guess?
That's my question.
Okay. I mean context T probably has a. Oh yeah, there's an example to be posted. But like also
Oh,
context T might have just an interface.
there's a GPipe. I haven't even seen this. Should probably have looked at this. GLFW default. Oh, okay.
Yeah, you could probably just copy that in, and then it would.
Yeah, this is like so much easier. Thank you, Toby. The old school way of doing things still works the best, I find. Anytime I find like just like an old blog or something, it's like, yes.
Yeah. I really I think ChatGPT just it can't. You have to be so careful not to overuse it. Is my only opinion.
Oh,
Like
yeah,
it's
yeah, definitely.
you know.
Now, though, I am curious. All right. It did figure it out. But, okay. The GLFW. Oh, hi. Hi. You need to go outside? I think she's telling me something. 1 second. Okay, yes. Whatever.
She's like, there's the squirrel at back.
Yeah, I gotta go get him. I'll just do that for now because that's what I had before. This. Okay. Okay, give me 1 second. Yes, let's go.
In the meantime, that's my dog. That's my dog. Oh, wait, no, this is on my face. There we go. Jenga. I know. Oh yeah, very happy. Very cute. You hear that, Jenga? She's off to her favorite place. We're going to her grandma's, so she gets very, very well fed there. They insist on making her like the finest possible food. Like they'll cook like a whole meal for her. Oh yeah, huge big ass smile.
Oh, Jenga. Hello.
Jenga. But yeah,
Cool.
I'll turn my camera off because I'm not nearly as cute.
Alrighty. Let's see where we're at. Oh.
So it looks like the new window part worked.
Yeah. That's good. Yeah, I didn't think that would work. I'm not sure what that is. Oh yeah, the uniforms. I'm not sure what to do with them yet. We'll just... We will probably have to bring that back, but let's get it working first. Yeah. I'm just going to use this example and see what they did differently. So we've got our window, got our primitives, got our viewport. It's on this. Rasterize. I mean, yeah, I've done this correctly. What am I doing wrong? Somewhere else. Two primitive. Oh, on this here, FST is wrong. Wait.
That type error might just be because it's not a tuple.
Yeah, yeah, I understand that part of it. I'm just wondering. What am I even doing? What is it? Isn't FST? That's the tuple function. I see what you're yeah, I see what you're saying. Oh, okay, yeah, we made it past that. Okay, actual type. Expected a fragment stream of frag color RGBA float, but we have a v4 v4. Why? Well, because we're creating one and turning it into one.
Why the heck is oh?
Oh, well, we're telling it to, so what if I just...
This stupid computer is doing exactly what I told it to do.
And now I'm just not returning the right type from the actual function itself. Let's take a look here. No, we're returning a renderer, and the shader couldn't match expected. Oh.
Oh, are you passing that syntax? Oh, is that valid syntax? Like, is those curly braces?
Where?
For line 75, is that curly braces?
Yeah.
Oh, wow. I don't even know that's valid syntax, but okay.
It is. I think there's an extension I used for that. I remember. But yeah, I mean, it's basically this.
Yeah.
I think there was a benefit to it, but I'm not 100% sure. Because this basically the same as just like you could just do, right?
Yeah. It's initialized some type of order. Right.
But what I think it is this is technically this, or whatever the
Yep.
actual syntax is. But there is a extension that allows you to, like, in, you know how like in JavaScript, if you have like the same, like if the left hand is the same as the right hand, you can just drop this.
Yeah.
That's what's going on here. Yeah.
Makes sense. I've heard about record wildcards. I didn't know it also gave you that. Like I know you could get the value
Yeah.
without like calling the type or whatever, or like it's just a different syntax, or like it put into scope each field as a its own value, but you have to explore the field on the type. But I didn't as well. It's cool.
I actually think it's name field puns.
Huh.
I believe they call it record punning. Yeah.
Very curious why it's a pun.
Yeah, it's because it's the same on both sides, so it's a pun. I don't know. That's a weird name.
Oh, clever.
Okay. Sorry, I got so distracted by the name puns. Okay, so yeah, the problem is that renderer, I actually think that we're probably returning the right, like, this is a compiled shader with the stream inside of it. Whereas if I go and look at our current definition of renderer, shader here, oh wait, maybe I read that wrong. Expected. Oh, wait. Why is it expecting primitive array triangles B2 float? Here. Primitive array triangles B2 float. To renderer.
Oh, so this is the type you've made. Yeah.
Yeah. That's why I'm thinking I just need to change this, but I'm just trying to understand this one. Actual compiled shader OS primitive array.
I mean, it's hard to tell what. I mean, at least for me, what it did before, what the design was before.
Yeah, I think what I'm just going to do, because again, like this was a lot of this was from porting from a completely different framework into this one.
Right.
So some of the just like the way things that we were doing things before doesn't align. So it could easily just be something like that. What I'm gonna do, the easiest way to do this, I think, using this technique that my good friend Galen taught me about, should tell us what the type is, right?
Indeed.
Standing for compiled shader, OS, primitive array. I just need to kind of understand what P0 and A1 are, but I mean, I can probably just.
Mm-hmm. Exactly.
Yeah.
And so now it's just a matter of since it's in our own code, it's an important distinction of just like well, why do we do that? And I think with just the step we're at in the project where we're porting to a new system entirely. I mean, personally, what I would do is just comment it out exactly, and then you can always like revisit if it makes sense.
Yeah, let's just try that. I guess it doesn't need the buffer. Is that really all this? Let's see. What do we got now? Okay, we still got our typo. Shader, OS, primitive array. Okay, so that matches now. Wait, what? Oh, I see. I'm just gonna undo the whole first. Why is it expecting? I'm very confused.
Sorry, what exactly are you confused about?
Yeah, so I basically just coded myself into a circle. So that's why.
Yeah, okay, can you just go back to so the type error, like the actual, why don't you just like copy that in?
This
Like
one?
what the actual is, yeah. This is just a type you made. You know,
No, I
like
know. Yeah, I know. I did that. So I did this here. Give me a second. And I guess I just leave P0 and A0 like as is.
well, you can change them to nicer names, but I mean, you could do that. There's no problem with doing that. You would just have to then make renderer specify what those types are.
Well, I know. So,
Right,
so for example, what if I want to? Can I also just do this?
Well, it depends if that type checks then. Like that's probably what you were coding yourself into a hole with there.
Yeah. Yeah, I don't really know what you're saying. See, that's what I did. I'll show you. All right, I try this. Then it gives me, okay, so then maybe it's that
I think does that work?
I do need FST, or maybe, I don't know. Because I changed that.
Wait, sorry, but wait. Why do you need a FST?
I'll put it back. I was just kind of guessing, because I had it there before, but like if you look here, it's now telling me that it's expecting there to be, I don't know. This is the error that I got before, and I like it, but the other way around, and I fixed it by going.
So what's the type of primitive stream though, or to primitive stream? Like, have we looked that up, or
what? Sorry.
To primitive stream? Like, what's the Google for that?
Yeah, I can get that for you.
Because right now we're just like guessing about.
Well, we've looked at it before, but this one here. Takes our primitive array. Or it takes a function that takes our primitive array. So right now we're currently just passing in ID.
Which
is what's in the documentation from GPipe. To be fair. Like this is exactly how GPipe says to do it here. But they're not showing like the problem is we're returning this from a function, so it's really just a matter of the type signature, I guess. And maybe like where else we've defined that, because we might have used renderer already in the code, so there might be something else, but I would expect it to show like maybe something we're doing in here is forcing it to like here we're doing tuple, I don't know. Canonic match expected type. Yeah, so here we're passing in this U, I guess, here. Yeah, this is the buffer. This is the uniform buffer that we're passing in alongside the primitive array. And so that is what's making it so that like up here it's saying, okay, we need to specify this buffer OS.
It also, like, it looked like from the Google that the type of S is determined by the shader T call.
Which one?
So, like, if you go back to the Google.
So I've got way too many open. Give me a second. I'm just gonna...
Sure.
Oh, I didn't open. Google for this.
So yeah. So see that the S is used in both the shader OS, S, and then in the higher order function that it takes. So it must just be getting that from the shader, like, so like what we could look at that at like the type of compile shader. That's what I would look at next. Just do like a typed
So
hole.
that'll determine whether.
Yeah. So I'm not quite sure how it gets that S type or chooses that S type based on your code, but like easiest way would definitely be a type hole on just compile shader.
Yeah. It's implicit. Oh. X. So it's not at this point. It's not defined, but it wouldn't be, wouldn't I? I think I would want to do this, right? Maybe. No, because that gives you, that's the compiled shader. Well, I'm wondering, like, I think I have a solution for right now. We'll have to, because right now I've already determined, like, I'm ignoring primitive arrays. However, why is that still?
I was on mute. Sorry. What's the prims? Like, where is prims getting used? I wonder if like it's getting its type information from rasterize. You know what I mean? Because like I don't see, like, it doesn't seem like two primitive stream would care whether or not you or like what the type is there, so long as it fits into the next. I see. There we have that vpos a, and that's the error you're getting.
Vpos. Give me a second.
Here, and you know what? Actually, now that I read this more closely, it's saying we expect that vpos a, but you're giving it, the type that you said in the renderer data type. So it is like, to be clear, like it's respecting the data type you said for renderer, but it's saying for rasterize that it's expecting something else.
Yeah, I would see that.
Hmm. Maybe
just trying to, where A is a fragment input.
And what is V? Like, you have to give it something that has the vpos. What is vpos?
Probably just it's a v4 vfloat, which okay. I see. So weird though. Like, I don't. Here's what I'm wondering though is like, why is it not return? It's got to be something to do with the data coming into primitive stream.
You said in the example that's what they did. So like, yeah, I guess what in the example is the type like for to primitive stream. I guess that's what you need to figure out.
Yeah.
So maybe
Because it depends where this shader is used now. That's where it gets the type
right.
for the input, right? Because this is like, it's not actually taking in the data. It gets it's the type from when the shader's used. Because like my question is, why is it giving me vertex format and not bpos if the to primitive stream function? Oh, that would be why.
Why?
Well, to primitive stream gives you vertex format. So I guess I need to map over. Oh shit! Yeah, that's why this was happening. But that doesn't work either, really, because that. Jesus. Sorry, Toby, where are you saying to put the prims for? Because at this point, we're getting close to the end. Yeah, this is the right idea. It's the wrong implementation. Stars expects a tuple of vpos. V4 float.
Toby, I saw you raise your hand. I'm not sure if it was a mistake, maybe, or
If you try to, yeah, you're just saying throw mute. You're saying throw unit into the A there.
yeah.
Try it, right? It'll problem. Yeah, so it would need prims 4. I think prims 4 is also just wrong. It's not actually giving me a
I do like Toby's suggestion though, because it might give us just a bit more type.
yeah, it'll give us
clarity.
more information. Yeah. So literally, you're just saying to do this.
I think in reverse. No, yeah, whatever. I don't think it matters. Or maybe Toby it matters.
Yeah, so it's v4, vfloat now. We just need to basically just say that that's a vpos. Well, I mean, you're not necessarily wrong because v4, vfloat is the same as. Oh wait, no, wait, what the hell's going on here?
I gotta drop. Peace out, everyone.
See ya. Oh no, yeah, because you would need. No, what it is it's a map over prims, but this isn't the correct map. This is the input. This is the output. So we need. What you're suggesting is this. Then this, we should probably just. I don't see why we can't just do that. We'll find out. No, we can't just use that. The legal term level use, type constructor. I think maybe then if we just keep it at v4, it might just. I don't even know what's going on now at this point. When in doubt. Back to where we started there. Keyboards. What did I do wrong? No, I didn't. Same. It's something I did a while back that's hiding. At this point, I'm just getting my nifty helper. I'm almost there, am I? Somehow I never believe this statement. Place your render type in the compile shader block. I don't really feel like replacing my code, thank you. Ensures the shader input type is paired. What the heck is shader input? Could be useful. If it exists. I don't want it. Oh, who would have thought? There's no such function. Piece of garbage. Yeah. Thanks everyone. I'm technically not. I'm just gonna stay on and try to fix this. But thanks everyone for joining. I'm gonna hopefully have this fixed for next week. But if not, it'll make more fun debugging. But yeah, bye. Please don't. That's what I had initially, but I don't. And that's correct now because I'm passing this in. And second, yes, that's correct.